Right, now we're going to be talking more about every different type of area that you can be asked to find underneath a normal curve. So every example here or every picture that you see here is these are the only types of area they can possibly ask you to find in any normal curve problem. There's no other type of area they could possibly ask you to find. So in the previous videos, we saw how to find this type of area where all you need to do is use the table. For this type of area, you're going to have to add. For this type of area, we're going to have to add. And for these two, we're going to have to use subtraction. So we'll look at some examples and we'll talk about exactly why we have to add here, exactly why we have to subtract here. And then I'll talk a little bit about how you can solve some of these on the calculator. This one and this one are going to be pretty much exactly the same to solve on the calculator as the examples we did in the last video. For this one and this one, the technique for the calculator is going to be a little bit different. Okay, so let's get to an example over here. We want to find the percent of data between z is equal to negative 1.03 and z is equal to 2.6. So the first thing that we're going to do here, like we do for all of these problems, is draw out a picture of the situation we have so we know exactly what to look for. Okay, so the normal curve that we have that corresponds to this problem is between negative 1.03 and 2.6. So we know how to find the area between 0 and 2.6. We can look that up on the table. We can't just look up this number and this number, but we can find this piece on the table. If we go between 0 and 2.6, we'll find this. And then for this piece over here, we can find the area between 0 and positive 1.03 because it's going to be the mirror image of that. And then we can add these two pieces together. First, we will find the area between 0 and 2.6. We'll just go right over here to 2.6. 2.6 is the same thing as 2.60. Go up here, that's 0, 2.6. This is what we have for that. So 0.4953. Now we're going to add this to the area between 0 and negative 1.03. That area, well, we're now going to look for 1.0, which is right here, and then go over to 0.03. We put those together. We have 1.03, and then we want to move down. Okay, so we have this one. So that's 0.3485. Now we add these two together, and we end up with 0.8438, or 84.38%. Okay, so again, this piece in here is 0.4953, and this piece over here is 0.3485. Okay, so if you draw a picture based on the numbers they give you, it comes out looking like this. Two pieces of area that are both touching the mean, you want to add them together. Now we'll look at a mirror image version of this problem where they're asking us to find the percent of data between negative 2.6 and positive 1.03. So we'll draw a picture again. So we have here negative 2.6. First picture should have looked a little bit more like this. This one actually should have been closer in because 2.6 is further away. That's positive 1.03. The area between negative 2.6 and 1.03. This is just the mirror image of the last problem. So the area between negative 2.6 and 0 is going to be 0.4953. And the area between 0 and 1.03 is going to be, again, 0.3485. So our answer, again, is going to be 84.38%. Okay, now we can talk about how to solve this on the calculator. Again, it's pretty much the same thing as what we did in the last video because we have a clear lower and upper limit. So if we were to put this in the calculator, we would go to normal CDF. Our lower is negative 1.03. Our upper is 2.6. This is standard normal, so our mean is 0, and our standard deviation is 1. And then we'll see what the calculator gives us. The calculator gives us 8.8438, which matches the answer that we got over here. If we were to use the calculator to solve this problem, we would get the same thing, but we could input it differently. Now let's move on to another problem. So we just saw an example where we're dealing with a piece of area like this. Now we're going to deal with an example where we see area like this. So here we want to find the percent of data above z is equal to negative 1.84. Another way that they could word a problem like this is they could say, find the percent of data to the right of z is equal to negative 1.84. Again, we're going to start by drawing a picture of the situation that they've given us. Our mean is in the middle. Negative 1.84 is going to be to the left of 0 then. And we're looking for everything above it, so that's everything to the right. So we want to find this area here. So we can find the area between 0 and positive 1.84. This is like just finding this piece of area here we can find directly from the table. But over here, this piece of area we can't actually look up on the table because this actually goes on forever, like towards infinity in both directions. The normal curve never actually touches down and hits this axis. It's always a little bit above it. And if we were to go to our table, well, the biggest number z-score we could possibly look up is 3.59. And we get over here 0.4998. We can't look up the number at the very end over here because this goes towards infinity. But if we remember from the first video we had introducing the normal curve, both halves of the normal curve have an area of 0.5. So what we know is this piece of area over here has an area of 0.5, and now this piece of area we can find from the table. This we can look up, add to 0.5, and then we'll know what the total area is under here. Okay, so we're going to go back to our table, and now we want to find 1.84. So we have 1.801234, 0.4671. So this piece of area is 0.4671. We're going to be adding the area between negative 1.84 and 0 to the area of the right half of the normal curve, or the area above 0, which is 0.5. And this is going to give us 0.9671, or 96.71%. And next we can look at the percent of data below or to the left of z is equal to positive 1.84. So this is going to be the mirror image problem of what we have here. We're going to get the same answer, but the picture is going to look different. So if we draw the picture for this problem, right, we're dealing with 0. We have positive 1.84, so that's going to fall to the right of 0. And we can shade in this area here. Again, it's pretty much the same thing we have over here, except now we're going to use this half, which we know is 0.5. And then this piece of area here is 0.4671. Again, we end up with the same answer. Now, if we want to solve this on the calculator, going off towards infinity like this, or going off towards negative infinity like this, gives us a little bit of an issue as to what we're going to put in for our upper or our lower limit. We'll go back here to our notes on how to solve these problems using your calculator. We're going to say here, you're going to approximate positive infinity with a lot of 9s, and you're going to approximate negative infinity with a lot of negative 9s. Let's see here, as many as you can fit in. So this is going to be for situations where, you know, you have positive infinity in this direction and negative infinity in that direction. So in cases like this. So what we would put in over here, normal CDF, we can see our lower limit in this case here. It's going to be negative 1.84. But here we're going off towards positive infinity. We don't have any number that we hit here. We just want to know everything above negative 1.84, which goes to infinity. So instead of infinity, we're going to put in a bunch of 9s. You can have a field day, put in as many as you want. You know, as long as you put in, you know, a good amount of 9s, you're getting as close to infinity as you can, or you're just telling your calculator, well, we're working with a really big number, and that's a good enough approximation for the calculator. our mean is 0, and our standard deviation is 1. So we put this in the calculator, and let's see what we get. We end up with 0.9671, which again is the same thing that we got here. Now, one important thing to note is sometimes with these problems, if you do not put in enough 9s here, your answer may not be as precise as it should be. It may differ a little bit from if you put in more 9s. If you put in more 9s, you're going to end up with a more accurate answer. This is more important in application problems that we're going to see when we get to them than it is for just typical standard normal curve problems like we're doing now, but just get in the habit of throwing a fair amount of 9s in there or negative 9s when you're approximating positive or negative infinity. And again, that rounds to 96.71%. If we wanted to do it here, well, now we have a negative infinity instead of a positive infinity. Right, so we would go back to normal CDF again, but now our lower limit is going to be a bunch of negative 9s to approximate negative infinity. Our upper limit is positive 1.84. Mean and standard deviation are still 0 and 1, and we end up with the same thing. 0.9671, which is going to give us 96.71%. So going back to this, general idea is when you draw a picture of your normal curve, you shade the area they're asking you to find, and you have a chunk of area that overlaps the mean. So we can break it up like, let's say 2 pieces here that are touching the mean, or 2 pieces here that are touching the mean. If you're using the table, you need to add them together. If you're using the calculator and you have something like this trailing off all the way towards the end, or trailing off all the way towards this end, you have to approximate positive infinity or negative infinity. Okay, so next we'll take a look at, we're going to look at this type of example next because this one's a little bit easier than that one. Now let's say we want to find the percent of data above z is equal to positive 1.7. So the first thing that we will do here is draw a picture of it. You should always draw a picture of it. So 1.7 is positive and it's above the mean. And we're looking for the percent of data above that. So we're looking for this piece. This is also sometimes called a tail end. So we're going from 1.7 to positive infinity all the way out here. Now first we'll talk about how to do this using the tables. We can't look up pieces of area like this or tail ends of area, but what we can find on the table is this piece of area in here. So we can call this guy A. We can look up the area between 0 and 1.7 and find this piece, and then we can use other information we know about the normal curve to find this piece of area. If we take this whole half here, right, from 0 to this, we know this guy is 0.5, and if we subtract this piece of area here, A, if we subtract this guy A, which we don't know what it is yet, this is going to leave us with the piece of area over here that we want to find, right? This tail end over here. So here we're going to need to subtract to find the area that we want. So we'll go back to our table and first find the area between 0 and 1.7. So if we go here, we go directly to 1.7. There's no other decimal after it. It's 0.4554. And then we'll do 0.5 minus 0.4554. And we end up with 0.0446 or 4.46%. And again, this makes sense because let's split up this half over here. If we look at another version of this picture, right, and we just look at the 2 pieces we have here, 0, 1.7, and this piece is 0.0446, and this piece is 0.4554. If we add these 2 numbers together, we're going to end up with 0.5, which is what the whole area of this half of the curve should be. So these 2 pieces should add together to give us 0.5, which they do. Now we'll take a look at the mirror image version of this problem over here. Now we want to find the percent of data below z is equal to negative 1.7. So first we're drawing our picture. Okay, so negative 1.7 falls below the mean of 0, so we draw it to the left. and we're looking for the data below it, so we shade to the left. Okay, so again, we're looking now for a tail, but this time it's going off towards negative infinity like this. This we would end up solving the exact same way that we solved this example. We can find what this piece of area is between 0 and negative 1.7. It's going to be the same thing it was up here, 0.4554, because of the symmetry of the curve. And then we would subtract that from 0.5, which is the total area of this piece of the curve, to get the area of this piece. .5 area of the left half of the curve. 0.4554 is area between negative 1.7 and 0. Okay, so we end up with the exact same answer. Now, in order to do this on the calculator, it's a little bit similar to how we did this type of problem on the calculator, where we had to approximate positive infinity or negative infinity when we're entering the numbers in. Again, because we're going off towards one end or towards the other end, we have to, again, approximate plus and minus infinity. So let's say, I don't have too much room here, but if we were to put this in the calculator, again, we'd go to normal CDF. Our lower limit here is clearly 1.7, and then our upper limit is going to be positive infinity. So we throw a bunch of 9s in there, 0 and 1, then hit enter and see what we end up with. It's 0.04456, which rounds up to 0.0446, which is the same thing that we had over here. If we were to put this one in the calculator, again, we would go to normal CDF. Now our lower limit is going to be negative infinity, so we approximate that with a bunch of negative 9s. Our upper limit now is negative 1.7. Our mean is 0, and our standard deviation is 1. If we put all this in the calculator, we end up getting the same answer we had over here, 0.0446. Now we're going to move on to the last type of area that they can ask us to find, which is when we have a strip of area like this between two positive z-scores or between two negative z-scores. Here we want to find the percent of data between z is equal to 0.71 and z is equal to 2.09. So again, first we draw out a picture of the situation so we know what to do with our table. So we have our mean in the middle, z-score of 0.71 and positive 2.09. So we can't just look up a piece of area like this on our table. We can only look up areas between 0 and some positive z-score. What are we going to do here? We're going to have to look up two different pieces of area, and we're going to have to subtract. What we can find from our table is we can find the area between 0 and 2.09. Then we can find the area between 0 and 0.71. Right, so just like last time, we could call this piece of area A. Right, so I guess we'll call that, let's make that look like an A. And we can subtract this, and then if we subtract this, we're left with, like A would be going over here, we're left with the area between 0.71 and 2.09. We need to go back to the table in order to do this. 2.0 is over here, 0.09 is over here, so we'll follow this guy all the way to the end, 0.4817. And now we're going to subtract the area between 0 and 0.71. So we go to 0.7, and then we go over to 0.1 up here. So 0.71, that is 0.2611. And then we subtract, and that's going to leave us with the area between 0.71 and 2.09. Which is 0.2206 or 22.06%. Now, of course, if we wanted to do this on the calculator, we see our lower and upper limit right there. So these are the numbers that we would put in. So we would do normal CDF. Our lower is 0.71. Our upper is 2.09. Mean and standard deviation are 1. And this gives us 0.2205. Okay, so this one does round a little bit differently. This is probably the more precise answer than what we had from the table, but either of these would be okay on a test. They're both answer choices on a multiple choice thing. Both of these would be right. So this one would give us 22.05%. And so both of these could show up as answer choices, and if you pick either one of them, they would both be marked right if the exam happens to be multiple choice. Now we can look at the mirror image version of this problem. Find the percent of data between z is equal to negative 2.09 and z is equal to negative 0.71. Again, we draw our picture of our normal curve with the information that they gave us, and we know this is the piece of area they want us to find. Now what we're going to do over here is the same thing that we did over here. We could first find the area between 0 and negative 2.09, which is going to be 0.4817 like it was up here, again because the curve is symmetrical, and then subtract the area between 0 and negative 0.71, which is going to be the same thing again. If we wanted to do this in the calculator, again, we can clearly see what our lower and upper limits are. So that's what we'd plug in. Mean and standard deviation are still 0 and 1. We would put this in the calculator, hit enter, and we end up with 0.22054 again, which rounds to 0.2205. Or 22.05%, which is close enough. So now going back to every type of problem that you could possibly be asked. Over here we subtract if we're using the tables, and what these two guys have in common is we're dealing with a piece of area that is not touching where the mean falls. So if you draw a picture and it ends up like this, right, whatever piece of area you are working with is not touching the mean, you need to subtract when you look up the values on the table. If the piece of area that you are looking to find does touch the mean, then you need to add the two together that you end up looking up. If you're working with the calculator and you can see what one limit is, but you can't see what the other limit is, it means you either are going to have to approximate positive infinity or negative infinity. Like negative infinity over here, positive infinity over here. And the way that you would do that is with a bunch of positive 9s or a bunch of negative 9s.